Hey guys, in this video what I wanted to take a look at was the idea that we can have data distributions using box and line plots. And one of the things that you're going to see here is that overall the shape of a graph is called a data distribution when you're looking at a line plot or a box plot. And a data distribution is this way in which the data is spread out or clustered together. The shape of the distribution is basically the idea of this hill that's being formed in each of these blue lines for these different distributions. So whenever a question asks, what type of data distribution does the data have, there's really only three possible answers. The data could be symmetric, it could be skew right, or it could be skewed left. And those are the key things to recognize that we'll be dealing with in looking at line plots and box plots. But the key thing is to always think about what is the shape of this general hill. Now, the two parts of this hill that we're going to be focusing on when we're discussing these are primarily the idea of this larger part right here, which we would refer to as the head, and then this lower part right here, which is usually called the tail. Over here on a skew right, the head is on the right-hand side, or a skew left, my apologies, and then the tail tends to be on the left-hand side. One of the general things to think about is whenever you're trying to figure out the direction of skew after you've drawn the hill, is just think that, well, in a skew left, the tail is on the left, and on a skew right, the tail is on the right. So in a lot of statistics classes, what they'll say is that the skew tends to go in the direction of the tail. Now, taking a look at how this applies to a normal box plot, we have to remember that a box plot will be divided into four main sections. Those sections are based on where the minimum, quartile 1, quartile 2, quartile 3, and the maximum are based. Kind of looking at what that's going to look like, the four different sections that we'll be focusing on are going to be quartile 1, which starts at the minimum and goes all the way up to Q1. Once you have quartile 1, you then also have quartile 2, which starts at Q1 and ends at Q2. You also have quartile 3, which starts at Q2 and ends at Q3. And then you have the fourth quartile right here, which starts at Q3 and goes to the maximum. This is the general idea that you want to think about with each of the normal box plots that we'll be taking a look at. And the key thing to remember here for a lot of these is that each of these quartiles, quartile 1, quartile 2, quartile 3, and quartile 4, all have exactly 25% of the data in each section of the box plot. So if we were to add up all of the percentages, you can see that this would cover 100% of the data. That's going to be very important when we start thinking about the data distribution, because when you're given a box and whiskers plot, you can't see where exact data lies within each region, but you can think about it in terms of these 25 percentages and thinking about what would it look like if the data had to stack up in each different region. So taking a look at what that's going to mean when we take a look at a box and whiskers plot, assume that you had a box and whiskers plot that looked like the following, and we were asked to try and figure out what is the overall amount of distribution that we would see here. So what you can imagine is those 25 percentages within each region spreading out. So think about 25 dots in this fourth quartile right here. Those 25 dots would be able to kind of spread out fairly evenly, and you might have a few that stack on top of each other, but for the most part, they're going to be fairly spread out. Or there's at least one dot down here at the maximum that's fairly further away from where a lot of the data might be packed together. Now, as we get closer and closer over here, we see that in quartile 1, there's a really narrow range that we would have to pack 25 dots in. So no matter how we tried to pack them, you could see that they would have to stack up more and more, and then they could kind of spread out a little bit more over here in Q2, but they're still going to be stacking fairly close together. And then you can see that here you can spread out a little bit more, and what you get is this really interesting idea that you can see how tightly packed and how high certain data will have to go. So drawing what a data distribution for this box and whiskers plot might look like, it might look something along the lines of this right here, which if you take a look at the shape would mean that there's a head on this side and a tail over on this side. Overall, what that means is that the tail
is
is
on
on the
the right-hand
left-hand
side.
side, and since we know that skew always goes in the direction of the tail, this entire distribution is a skewed right distribution based on the box plot. Taking another look at a different example, we can see the same thing going on here in the idea of trying to pack in 25 dots. Well, looking at how much space I have right here, if I were to just pack in, let's say, 5 or 6 dots, you can see that I'd have all this space, but then if I try to pack in 6 dots right here, I have to stack to almost 3 high. And here I get the same amount of space, so I could stack 3 high, and then I get to spread out those 6 dots again. Don't forget to put a dot here. And I'd even put a dot right here at the minimum, and taking a look at what the data distribution might look like, it might look something along the lines of this, where if you take a look, there's no clear head, but a lot of the data is in the middle. So we could say that the head is in the middle with 2 tails on the left. Well, in this case, because most of the data is in the middle, we would actually say that this is a symmetric distribution of data. And we wouldn't really say that it has any skew at all. Now, some things that kind of get complicated here is when you have these types of box and whiskers plots. These box and whiskers plots are a little bit more complicated because you can see that there's no clear evidence of where Q2 lies. So taking a look at what would happen here, we have 2 possibilities. There's one possibility where you have your minimum and maximum. You have your Q1 and Q3, which will always be the start of the box. But in your first possibility, what happened was is the normal dividing marker, Q2, which would have been right here, has moved over to line up with Q1. The other possibility is that that same marker, which is right here, Q2, has moved all the way to line up with Q3 so that you can't really see where it is. So when you have these types of distributions, it's a little bit trickier because you have to consider 2 possibilities. So let's think about what would happen if we did possibility number 1. And what we're going to do is we're going to color possibility number 1 in kind of this brownish color right here. So taking a look at possibility number 1, I know that I need to put a single dot right here at the minimum. And if I use, let's say, 6 dots for each compartment, I know that I need to put 6 dots along this first quartile. Now knowing that I need to look at what would normally be quartile 2 would normally be right here. But if you remember, we pushed this red line all the way back over to start at Q1. So I have to immediately put 6 dots right here to account for that whole section that got smushed together. And then realize that there's another 6 dots that can stack up in here. Well, I can see I might have to put another dot right here. And then I space out 6 more dots over here. Well, if I had to draw a data distribution in red here, I could see that it might look something along the lines of this right here. And if I did that, according to possibility number 1, this would be a skew right distribution because the tail over here is primarily on the right with the head right here on the left. But now let's consider the idea of what if we did possibility number 2. Taking a look at what would happen with possibility number 2, let's say possibility number 2 right here is in blue. Well, I know that I need to put a dot on the minimum, and then I need to put a total of 6 dots in all between the minimum and Q1 right here. So taking a look at what that would look like, we get nothing really interesting that's different. But now, in this instance, Q1 is going to be able to say, oh, Q1 starts right here and stretches all the way over to Q2, which is going to be on this side. So really, I get to space these 6 additional blue dots out into the beginning of the box, and I get this right here. Then I get Q3 and Q2. Well, remember, there were 6 dots in this box, but they've now all been pushed over to right here. So they all stack up right on top of this dot. So these 1, 2, 3, 4, 5, 6 blue dots that I just put are all right here at Q3. And then I put another 6 dots to show where quartile 4 is. So if I drew what this data distribution would look like, it would go something along the lines of this, which gives us the exact opposite data distribution that we had right here in possibility number 2. So knowing that we have these 2 different possibilities, I know that this overall data distribution, and just to hide that, what it would look like, this distribution right here really has no answerable way of addressing the question because, given the two possibilities, one of them is a skew left, the other one is a skew right. So the best answer that we could actually come up with for this particular example is not able to determine. So whenever a data distribution question is given, there is the possibility that you may not be able to determine exactly where it is. So it's always important to keep that in mind. So I hope that this video is able to tell you exactly how to look at a box and whiskers plot and answer what the data distributions are. The only other thing that you might have a question about is, well, how would you look at it for a line plot? Well, if you have a line plot, just remember the one thing that you can do is go back to which of these data distributions that we started with does the line plot look most like, and don't be afraid to actually draw the shape of a hill above it. One important thing to note about a symmetric distribution here is that notice that it does not have to be perfectly symmetrical. It just has to be most of the data in the center of the distribution. So if you end up with most of the data in the center, you can absolutely say it's symmetric, even if it is not a perfect mirror image on the left side and right side. If you have any questions, feel free to give me an email, comment on my videos, and I will be more than happy to address them as soon as I can get back to you.